Hello everyone, welcome back to lecture 20 part 2. Last lecture we talked about polarization and as well as we talk about linear polarization. This video we're going to talk about circular polarization. So as you know that, this the time domain signal of electrical propagation is right here. Only difference is here, my delta now is pi over 2, positive pi over 2. So right here, so delta could be positive pi over 2 or negative pi over 2. And x is equal to ay, and that is equal to a. That's the assumption here. So that ax and ay becomes a over here, and your delta become pi over 2. So with that, if I basically go one more step, and with the trigonometry, this sign becomes your negative, and cosine becomes sine over here. Is all trigonometric manipulation. So from there, if I try to find the magnitude of my propagating signal, that becomes a, right? So now look at that. Its magnitude of the propagating signal is a. It's not changing. It's always the same thing. Remember, last one, you're going back and forth. Your magnitude change, right? But this here is not changing. It's always a. Now your inclination angle C is also right here, all right? So now if you look at this one here, so if z equal to 0, right, I have what? I have C equal to negative omega t. What it means? It means that if t increases, your phi decreases, right? Because of negative sign. So that only possible if you're going into clockwise direction. In clockwise direction, your angle is always negative. So if you if a tip goes into clockwise direction, your C increases, but C decreases as time goes by. So now, if you look at here now, let's see here. This is the tip of the vector. This magnitude is always a. This magnitude is always a. It's not changing, right? So tip of the vector magnitude always a is traveling into the clockwise direction. Is clockwise direction changing? So and you see always decreasing, because clockwise direction your angle is negative, right? So that is called left hand circle polarization. Left hand circle polarization. That means if you have a left hand, if your forefinger represents the movement of the tip of the vector, then your thumb should be representing the direction of propagation. So if you do it here, your propagation signal is coming out of the face, and your forefingers is representing which way your tip is moving or Lucas is moving. So polarization handedness is defined the term of the rotation of E, that's your tip of the vector, as a function of the fixed plane orthogonal to the direction of propagation. So you're looking from the xy plane at z equal to 0, which is opposite to the direction of rotation of E as a function of distance at the fixed time, right? So this one is the clockwise rotation of the vector. Is give you the left hand polarization, all right? And now if we do other way around, if you go on now counterclockwise, then your right hand, forefinger of the right hand will give you the direction of the E vector is moving, and your thumb will give you the direction of the propagation. All right. So now let's say here for this one we have already have done that. This is the left hand circular polarization. We talked about that. It basically what I said is basically showing in written form over here. So that's same angle came over here. You can see that. And also this magnitude came over here, so all good. Now if we do right hand polarization, what is the changing over here? Your angle, what is delta again? Delta is the like phase angle shift between x component and y component. So if it's negative pi over 2 or negative 90, and this is not changing, right? It's same thing, but your inclination angle is now positive. That means what happening over here at z equal to 0, psi is omega t, right? So it increases, that means that psi also increases. That means if you go this way here, your angle become positive. So that means your tip is moving this way, right? So now your forefingers of the right hand can represent the movement of the vector tip, and your thumb would be giving you the direction of the propagation. All right. So we're gonna do this problem in the class. So give you more insight to the polarization. Next. lecture, we're going to get into the elliptical polarization.